Okay, sorry, the video cut out, so I started over again. If I was going to, we have no unit for work divided by mass, but if I was going to name it, I would call it gravitational potential. All right, so now let's come over to this equation. Look, you've all heard, say, let's say we have a 9-volt battery, or in your car you have a 12-volt battery. 12-volt battery means that that battery will do 12 joules on every coulomb that's in it. If I had an electric field, I can actually think of it like this. If you have a 12-volt battery, what you actually have are two plates, one that would be positive and one that would be negative. And positive charges are going to move across there, just like an electric field. I mean, like a gravitational field. And what would happen is, right at this point, this would be 12 joules per coulomb. So if you put in 1 coulomb of charge, it would be 12 joules as it fell, went from here to here. But if I put in 1,000 coulombs, it would be 12,000 joules as it moved from one place to the other. If I went halfway across here, so that this dropped, and as we were going through this field, remember these are two parallel plates, field would come down. Right here, you would be at 6 joules per coulomb. I wish I could show you something. If we come back to school after Easter, I'll show it to you. It's really cool. I have a plastic tub. I put 2 parallel plates in. We measure the voltage. We put salt water in between. And as I move the probe of my voltage meter, the voltage drops because you're only going part of the way through that electric field. So this is our understanding of voltage. That's actually the unit. The voltage difference is the work on Q1 divided by Q1. Tell me what the work is that you're going to do, how many joules, tell me how many coulombs, and you'll know what the voltage was. Of course, this could be rearranged. V times Q is W is the way it's normally thought of. And then what's interesting is there is another equation for voltage, and that is delta V is equal to the electric field intensity times the distance. Now, if you say, well, wait a minute, what is electric field intensity times the distance? Just a second. If you go back to before, electric field intensity is force divided by charge. So watch this. Delta V is force divided by charge times distance, and force times distance is the amount of work. So this equation, if you simply know the electric field intensity and the distance that you're going to move through it, you will come up with the amount of voltage. If you know the work and the charge, you'll know the voltage. If you know the voltage and the charge, you'll know the amount of work. So these are actually very straightforward equations. Let me move over here so you can see it. In fact, I'll do it this way. We'll turn it so you can see it. This is your fundamental equation. WV is equal to change in voltage is work divided by charge, or work is voltage times charge, technically change in voltage. And V is equal to Ed, my favorite equation in all of physics. Voltage is equal to Ed. Now, I know I've gone through that quick. There's going to be a time next week where we can answer questions. I'm going to have office hours, and I'm also going to have class schedule. So there's a chance to ask questions, and maybe I'll show you that demonstration I was talking about. Let me just end with this. When we're talking about voltage, let me explain now, maybe you can catch it, why it doesn't really matter how much voltage you have. If I was to tell you, you're standing on Earth and somebody has something lifted, let's pretend gravity, there's no air resistance. Somebody's holding something that is 10 meters above your head and they're going to drop it. Should you be afraid? Well, the next question is, what are they dropping? If they're dropping a feather, no. If they're dropping a single atom of uranium, no, I'm not worried about that. But if they're dropping a safe or a 10-pound weight, yeah, from 10 meters, it's going to kill me. In other words, it doesn't